Hello? Hello, hello. Yes, yes. Okay. Hello, hello. Okay, let's get started. Let's have a look of Lab3. Before we start, I would like to share this link to you, which is the GitHub link. So you can have a check of the tutorial link in the table and the recording as well. You can click the recording and you can have a review of the recording. And you can feel free to join any lab if you want. As well as some general questions regarding to the labs. For example, for this week's labs, you may need to have a look of the how to use the linear regression and how to calculate the R-square value. I will share this link to the chart. And also you may find this link is very useful for you. It is the quiz for last year. So you may have a try before you attend the real quiz. Okay. Today in this lab, we just have a look of the Lab3. Let's have a quick look of the Lab3. So what are we going to do here is to collect some data related to the line of sight environment. So what is line of sight? Let's have a look. So what we need to do is basically the same as Lab 2. Do you still remember what have we done in Lab 2? We collect our own data in task 2, right? Just use our mobile phone as our hotspot and use our laptop to connect to it. And then use the Wireshark or network monitor to start capturing. And at last, we use the Wireshark to export to CSV file and analyze it. And that's all we need to do in this lab. Let's have a look of it. So our task, the first one is to capture the RSS data. You can see. But this time is a little bit different because it is not capture the single stuff. We are going to capture different data sets. You can see here, it's different distance. So how many? We need to capture 10 for indoor and 10 for outdoor. So totally is 20. You can see here. So there are 3 steps to tell you to do how to do that. The first step is just create a hotspot and connect to it. I don't think I need to talk a lot about this one because it's very easy and you have done in lab 2. And step 2 is place the laptop at the corner of the indoor area. So let me open a link here. What should we need to do? Let me draw it. You can see we need to mark 10 equally distant spots at our room, right? So I assume this one is our room here. Yeah, for example, this one is our room. And then we can put our laptop. This is our laptop. We can put it here. At the corner, right? And then where is your mobile phone? You can put your mobile phone here. And what you need to do is you may need to draw a line to help you to do this. You can see the distance between the hotspot and the laptop. You need to slice them into 10 pieces. Maybe you need to mark on the ground or something. And then what you need to do is you stop capturing at the longest distance at first. And then after this capturing, you move away, like move forward to your laptop and start capturing again and move forward again and just do this for 10 times. And what you need to make sure is for each distance, it should be like equally split. Yeah. For example, you should put your mark on the ground like this. You should some marks. Split this line to 10 different sizes like this. Does that make sense? So you just move your hotspot to every single spot again and again. So you will get 10 different files. So here is 1, 2, 3, 4, 5, 6. Only 7 here, but we should put 10 spots on this line. Okay. And another important thing is make sure laptop has LOS. So what is LOS? This one is very important. Line of sight, which means there should have nothing between the hotspot and your laptop. For example, you should not stand between them when the capturing started. You should not stand here, okay? And there should have none, like they should not have any obstacles between the hotspot and laptop. For example, you have a table here. You have table here. Is that okay? Yeah, it is okay because the table is not between the laptop and hotspot, right? If you have a table between them, it's not really okay. So what you need to do is keep them clear, keep this way very clear. You should have nothing between them. So when you stop the capturing, you should not stand between them, okay? Okay, let's go to the step 3. So when you stop the capturing, you should like have at least 1 minute to make sure you have enough packets to use. You can see it requires 200 to 600 data. And save it as a CSV file. So does that make sense? Do you have any question related to that? For example, my data have 10 meters as my file face weight. So my point on here is 10 meters. This one is 9 meters. So I will get 10 different CSV file and save it into my desktop. And then I can start to use this file to help me to generate my report in the second task here. But your room may be like different. Like for this one, you may have only 0.5 meters, and this one should be the 1 meters. It depends on you and depends on the size of your room. So do not just don't worry if you have different distance as mine. And when you go to the outdoor, like you go to the outdoor here, you should keep remain the same distance as indoor, so you can compare them. Okay. So let's go to the second task. Yeah, when we got these 10 files, 10 for indoor and 10 for outdoor, what should we do? We should start to plot something. We are going to plot the raw Rss data against distance in log scale, this one, as well as the average Rss value. See, we are going to plot two different graphs. The first one should have the raw Rss data, and the second one should have the average Rss data. And then we need to fit a straight line to the average Rss value. So which one we use the linear regression to help us to draw this one, and as well as the R square value here. We use the R square value to help us to like evaluate our regression model. And that's all. So let's have a look of it. So for the data collection part here, all we need to do is just have a mobile and laptop, so we can start to do the first task, right? For this task, we need to prepare our laptop and mobile, sorry. Why laptop instead of desktop? Because we are going to capture our data outside. So you'd better have a laptop to help you to do so. And if you are using Mac or Linux as your system, you may require Wireshark. If you are using Windows 10, you may need to use Network Monitor to capture the packets. So again, for this task, we need to do is capture both indoor and outdoor data sets for 10 different distance and save it as a CSV file. So we will have 20 files at last. And we should remain the LOS condition as I mentioned before. There should have nothing between your laptop and your hotspot. Okay, so I think that's the key point for the data collection steps. And let's go to the next one, report. So what should we have in the report? We should have a raw RSS data and the log distance graph. So what it is? I can show you on the graph. It's something like this. So you can see the x-axis is the log scale distance, and the y-axis is the signal strength. And the first graph we mentioned is the raw RSS data. So that's the reason why there are lots of scattered over here. And the second plot should be the average RSS data. So you should calculate the average value for this and plot only 1 point for each distance. And after that, you need to calculate the slope. So just do a linear regression to calculate the slope. So you can see here's an equation for that. As well as the R square value. Does that make sense? Do you have any question regarding to the how to calculate the slope or how to plot or other thing? If no, we should go ahead. So sometimes we will make some mistake on our data collection step. So that's okay. For example, here, when I try to capture all the data at the longest distance here, you can see, you can know my data set is 1 meters, 2 meters, 3 meters, 4 meters, 5 meters, and 10 meters, right? And this one is 10 meters. This one is 10. And this one is 9. And this one is 8. But I made a mistake when I collect the data. So you can see the average RSS, the signal strength, in 8 meters is even better than 7 meters, right? This one is 7. So it's weird. So I should consider these 3 as an outlier in my plot. So what is outlier? You can find it on the graph here. So when you fit in the line, so you should delete some outlier if you think you made a mistake on data collection steps. Okay, so here I think I made a mistake when I collect the data with 8 and 9 and 10 meters. So I just delete them from my data fitting here. So you can see, at first I fit my line with all the scatters here. But in this second graph, I only use the first 7 data to fit my line. So I delete them because I think they are invalid data. So you can do this if needed. Does that make sense? So your data set may be very perfect and you do not need to drop any of them. But if you do have some like outlier, you should drop them to fit your line, to make your line perfect. And what's next? About how to plot. You can use the Excel, Python, as I showed in previous lab, in lab 2, about how to plot a graph on Excel and Python, or any tools you like. And how about the linear regression? How can we calculate the slope? I have made some, let me see, GitHub. Here. I put the link here, so you can have a look of how to use the linear regression function in Excel and NumPy. So here is a video. So you can have a look of it. It's a 5 minutes video. Watch it if you need it. It's pretty simple. And the NumPy, you can use the NumPy polyfit to calculate the equation. And how about the R square? For the R square, we can use the calculator. So at first we need to know what is R square value. R square value. So you can Google it. Basically, it's just a measurement of the correlation of the regression model. So we use this value to measure our regression model. So let me have a demonstration here. So the data set X, what is that? It's our log scale time. For example, in my plot, you can see 0 is minus 28, right? And this one is 0.3. It's about minus 41. And this one is 0.5. It's about minus 45. So I just put the X value here. The X value is 0, 0 0.3, 0 0.5, 0, 0 0.3, 0 0.5, and the minus 28, minus 41, and minus 45. And you can click the button and calculate the R square value for these 3. But all you need to do, you should put all the scatter here, into the box and calculate them all. Easy, isn't it? Or you can use Excel or Python to calculate it if you get the equation. That's all, I think. Another question is, what if I can't capture the packets? Some students still cannot capture any packets on their computer. So at first, you need to make sure you have the right configuration. For example, I'm using Windows 10 here. So run as administrator. And then you need to make sure you select the Wi-Fi here. You can see, select Wi-Fi, and you should be able to see your IP address. Then you can like double click it and have a double check, and you may be able to open the monitor mode here, but my one are not able to open it, but I can still capture some packets with it. You can see I can click new capture, and I click the start button here, or use the F5. Click the F5, and you can see there are lots of packets inside here. And to increase the traffic from your computer to outside, you can play a video while you're capturing, or you can simply use a command line ping to ping your server, ping your hotspot, okay? So the easiest way is to open the YouTube and play some random video. I'm not going to do here. Stop, and then I can use, I need to save it. Save it. Let's say Lab3 2. And then we can use Wireshark to open it. It's something like this. So you can see there is no AO2.11, which is the raw wireless package inside here, but I can still have some signal strings information here inside the UDP and TCP package, so I can use them. Does that make sense? So don't worry if you cannot capture the noise level and signal to noise ratio. We are not required to use them. So all you need to do here is just apply a filter about the SSID or the source IP, and you'll be able to filter them. And you can output them as a CSV file. Does that make sense? So I can't capture the AO2.11 package. So if you be able to capture the TCP and UDP packets, you'll be fine, and you can use them. So if you still cannot capture anything, like if you are using Mac or Linux, and you find you are not able to capture the packets with Wireshark, and at first you should check the configuration here. You should open your monitor mode here, but I'm using a Windows 10, which is not able to open the monitor mode here. But if you are using the Mac, here should have a box. You should click it and start. Okay. But there is some interface did not allow you to capture the signal strength. So it may happen. So you can borrow a laptop or use a old laptop to help you to do this, or you can simply buy a wireless adapter. Let's see this one. So okay. So if you have a wireless adapter, it can help you to capture the packets you want. Hi, for the R-square calculation, do we have to get the exact log10 distance for the x value, or we can get the estimate value? Like you should get the exact x value. Yeah, but it should be very easy, isn't it? For example, my distance is 1 to 10 meters. I just input into the Google. Okay, you can see the log value is very easy to calculate. You can see log 10 to should be 2, something like that. And these two graphs is only for demonstrations, so we should not be the same. So do not worry if you got a totally different graph as mine. Okay, this two is just for demonstration here. You may have totally different value here, here, here. That's pretty normal. Do you have any question? I found the SS value in packets captured by network monitor is positive, but ISS is negative. Why? Okay, just don't worry about that. It should be negative. It should always be negative. You can have a check, like through the Google signal strength, right? You can see the range should always be negative. I think they just omit the negative symbol. And I think that's all for today for the lab. So if you miss something in this lab, you can have a review in the recording in this link, the GitHub link. You can click this link. I will upload this recording later. And yeah, if you have any question, just feel free to stay here. And you can open your microphone and share your screen if you want. So after this lab, I think this lab should be the last lab for this week. So if you still have some problem during the weekend or something, you can post it on the forum. And we will reply you in 24 hours. When can we get lab 2 marks? By the end of this week. You'll be able to get your lab 2's marks by the end of this week. And yeah, and that's all for today. So if you have any question, just stay here. But if you don't have any question, just feel free to leave. And see you next week. Bye. How do we convert the positive signal from the network monitor to the correct negative values? Okay, let me see. For example, here, uh, open it with Wireshark. What do you mean this one? Signal strength. So let's see what if we can uh, like output as a CSV file example. Yeah, and let's see. See the example CSV file here. It is positive value, right? It's quite weird. I may have a double check of it, but for now, maybe you just simply add them a negative symbol by your hand. Yeah, it shouldn't be positive. Yeah, I'll have a double check of it. So for now, if you just apply them as consider them as a negative value. So if I made a mistake, you will not have any penalty for that. Okay. Just consider them as a negative value. So if I will also talk with other tutors, see if they have the same problem. So if I made a mistake, I will tell you in next lab. But I think that they should be in negative value. So when you plot the graph, just use the negative value. Because the higher the signal strength, when we convert it to the negative, it has lower signal strength. Oh, really? Oh, yeah, I know what you mean. But you can have a look of mine here. I can open one of my file for you. This one. This one is for, oh, this one have minus 28. Oh, why? Okay, it seems sometimes it happens. I'm not sure what happened with that, but we should have a double check of it. I think it is because I'm using my desktop to, to capture the wireless signal. And when I use my laptop, it doesn't have this problem. So you may have a check of your file. So at first you can have a like small experiment on your computer. For example, you can do like this. Where's my, yeah, yeah. So you can have a check of it. So at first you put your hotspot at a close distance with your laptop, for example here, and then you can capture a file and save it. And then you move away from your laptop and capture. And you can compare the value of them and have a look of it. So it is very clear that if you put your hotspot away from your laptop, the signal strength should be less than when you put your hotspot next to your laptop. Does that make sense? But if you found them, they have the same value or they have like very similar value, then you should report this to our forum or maybe change your computer or use another like wireless adapter to have a try. I think this is mainly because I'm using a wrong wireless adapter. That's the reason. You can see my adapter is, I can't see it. This one. Nope, this one. The killer. I think the killer doesn't support us to help to capture the data we need. So maybe I should change another wireless adapter to capture the package. But when I'm using my laptop, everything is fine. So you can have a test of it at first and see how it goes. Just put the hotspots in different distance and have a look of the signal strengths and compare them. If they remain the same, then you may have some trouble. Maybe switch to another laptop, I guess. Yes, let me know. You are trying, right? Okay. You just finished the indoor base. That makes sense. See you next week. I finished capturing, and the close hotspot has around 49 to 55, and the far one has around 35 to 41 dBm. Oh, so which means you have very strong signal. So that's your like network interface is an advanced one. So this makes sense. So if everything is makes sense, so you can use them. So I guess the power of your network interface should be very strong. Yeah, just explain them in your report. But this one makes sense. So you can explain them. So don't worry if you got a positive value. It's really real, I think. So don't worry about that. If you got them correctly, you can see the closest one, you have the higher value, right? And the far one have a less value, which is makes sense. But you can explain them why you got a positive value. Hi Ray, I'm from your class yesterday. Will it be okay for me to ask some lab question here? Of course. Feel free to ask any question. Tunable screen sharing. Yeah. Okay. And share your screen. Okay. You got a positive value as well. But I can't hear you. Did you open your mic? Oh, you can type. Your RSSI is 61. Yeah, very strong signal. I can't hear you. I'm not sure if you can open your mic.
Can you hear
Okay.
me?
Yeah.
Oh, okay. I think it was, yeah, I was using the wrong mic. But yeah, so is positive is positive like wrong?
I think positive is okay. Just explain what happened. So why you got a like positive value? Because I guess the power of your network interface is strong, and your Wi-Fi router is pretty good.
Okay, I see.
But like in this lab, you should be able to find for the longer distance, you will have less signal strength, right?
Yes.
So that would be fine.
Yeah, okay. And um so I was capturing for around 1 minute on the Windows network monitor, and 1 minute gave me like
Yeah.
8,000 something, like
8,000. Oh yeah, I see. So what happened is, did you could you please open the configuration here? The configuration, yeah, in left corner, the fourth one. No, it's not here.
Which one?
Yeah. The configuration. No, not. You can open that one. Capture option. Yeah, this one. Why we don't have anything here?
It's a different computer, so.
Okay, so when you on that computer, you should like click a manage interface, and you should not capture all the stuff from every interface. All we need is only the Wi-Fi interface. Okay,
I
but
think I did capture Wi-Fi only though.
but that's fine. It's a good thing you got a lot of packets here.
Okay, so it's okay if I just use all these packets in my
Yeah,
analysis?
yeah, of course. Why not?
Okay. So the other question I have is, let me change my. So these are all my data.
Yeah. Okay.
Um,
Sounds good. It looks
yeah,
pretty good.
but the spread is very like not visible in the raw value.
Oh, why?
Yeah. So this is the raw.
Raw.
Business.
Yeah, but
I
why
think
only 1 point for each
yeah.
distance?
So I don't know why.
Yeah.
Is it?
You should show all the distance.
Yeah,
Sorry.
I made it so it's
Mm,
I selected all the data.
yeah.
So like here, for example, I have the entire column of data selected, but it only shows
Uh,
one dot.
yeah, it's pretty weird.
Yeah. Is it because it's all 53? No, there's some 54. Yeah, so maybe it's an Excel problem. So it shouldn't be a
Yes.
single dot, right? It should be.
Yeah, it shouldn't be.
Okay. I should change it then. And also my
Yes.
average looks like this. Does that look right?
Yeah, it's pretty good. In my point of view, it's good, very good.
Okay, that's good then.
Yeah,
Yeah.
but if you found some outlier, for example, for example, I'm not 100% correct here.
Mhm.
Did you see the 41? The
The
ISS value
40.
is
Yeah, this
41.
one.
Yeah, maybe you should consider that one is an outlier.
Yeah.
Yeah, maybe I'm just suggesting, but not 100% right.
Would this also be an outlier, the last point?
Yeah, so you can just explain them. Which point did you consider as an outlier and why?
Okay. And also that the lab said to plot as linear,
Yes.
but wait, how do I to plot as linear? But the line that I was fitting was
Yes. It's
I
not
fitted
linear.
a logarithmic line because it's a logarithmic
Yeah.
scale. Is that right?
Um.
Here. So
Okay.
I fitted a logarithmic because if we fit linear, it looks like this.
Oh, it's pretty weird. But I didn't use Excel to generate this plot, so maybe a straight line would be better.
Yeah,
Yeah.
right?
Straight line
Okay.
would be better.
It's because this
Yeah.
axis is logarithmic. I think that's why.
Yeah. Oh yeah, that's the reason.
Yeah. Okay. That was all my questions. Thank you very much.
Okay. No, pretty good.
So it's the positive signal strength is just because it is a lot higher than
Yes.
there's like very high gains.
Yes,
Like
I think so. Very strong power.
Okay. And when this is for indoor, so when we do outdoor,
Yes, of course. We
is
need
that
to
just
do
any?
both indoor and outdoor.
Yeah, so is outdoor just any place outdoor? Because we don't have, it doesn't make sense to do a room outdoor.
Yeah, I mean, you can go to the outside no matter where it is. Like you can go to the park and
Okay.
use the same distance
Okay, I see.
and
Yep.
see what is the difference.
Yep. Okay. Great.
Yeah,
Yeah,
because you should consider like what is the weather and what is the wind, something like that, and what makes the difference.
right, I see. Okay, I will do that then.
Okay.
Thank you very much.
Okay. See you next week.
Yep, see you next week.